So I noticed when I was looking at some of your practice review assessments that some people still struggled with the factoring. So let's review the 3 problems that most people got wrong. So first thing, when you're looking at a trinomial, you always look for your GCF. So you need to divide out a 3. And when we do that, we're left with 2x squared plus x minus 15. Now I'm going to highlight that because you have to continue to factor and break down. So now I'm going to try to break down 2x squared plus x minus 15. For any trinomial, you're looking for combinations that multiply to a times c. So a is 2 and c is negative 15. So what combinations, if any, multiply to negative 30 that add to b, that add to 1? So we know 5 times 6 will multiply to 30, but we need to multiply to negative 30 and add to positive 1. So we know the negative is with the 5. So negative 5 and 6 are our combo. So then we have x minus 5, x plus 6. Now remember, when the leading coefficient is something other than a 1, we need to have that denominator under the 5 and the 6. We put that front number of the trinomial we were breaking down, so it's a 2. Simplify, swing out. So 5 over 2 doesn't simplify, so the 2 comes in front of the x coefficient, so we have 2x minus 5. And 6 over 2 simplifies to 3, so we have times x plus 3. And then that GCF that we took out in the very beginning drops down. Now notice, when you're factoring this green trinomial, right, you're breaking it down. If you thought you were done when you had x minus 5 and x plus 6, which a lot of people did, if you FOIL that and distribute, you would get x squared minus x minus 30, and that's not 2x squared plus x minus 15. So now let's look at the second one. There's no GCF. Yeah, James? I'll show you after. I'm being recorded. Excuse me, everybody. My son's trying to make a paper airplane. So you look for what multiplies to 2 times negative 3, which is negative 6. That adds to 5. So you'll get 1 and 6, and the 1 has to be negative. So then we'll have x minus 1, x plus 6. And we do factors over the front number of the trinomial we're breaking down. So it's a is 2. Simplify, swing out. 1/2 doesn't simplify anymore, so the 2 comes in front of the x. So we have 2x minus 1. And then we have x plus 3. 6 over 2 simplifies. And you can always check. This is our final answer. But you can check, because if you FOIL and you distribute, you will get 2x squared plus 5x minus 3. Okay, now this next one. There's a few ways you can do it. When you look at this, the first thing that I did is look at the center, and I simplified so that I have a trinomial. Like terms, negative 2x and 9x. So we get 7x, right? So we say the problem is 3x squared plus 7x minus 6. So there's no GCF. We're looking for a combo that multiplies to a times c. So 3 times negative 6 is negative 18. That adds to 7. So we know it's some combo of 9 and 2. If it has to be positive 7, then the negative's with the 2. Now I'm going to practice factoring by grouping. So you could do the last method I just showed you, or some of you like to group. So remember, what grouping means is you take your factors and you can replace your middle term, right, with the factors. And so when you do that, you then would say, you could go like this. So 3x squared plus 9x minus 2x minus 6. And then you ask yourself, what's the GCF of the first two terms? So you're grouping, right? So our GCF is 3x. And we're left with x plus 3. Over here, if we take out a negative 2, we're left with x plus 3. Now notice, both of these sets, right? 3x times x plus 3 and negative 2 times x plus 3 both have an x plus 3 in common. So we write x plus 3 one time. And the terms that are left are the 3x and the minus 2. So we have 3x minus 2. So that's factor by grouping, okay? For all of these problems, you can do factor by grouping. And if I FOIL, if I distribute, I would get 3x squared plus 7x minus 6. Or if you wanted to do it like I did in example 2, if you wanted to do it that way, I'll do it that way also. You would write, if you chose to do it like example 2, once you found your factors 9 and negative 2, you would write x plus 9, x minus 2, and then you do factors over the front number, so the front number is a 3, so over 3, simplify, swing out. So if you look over here, the 3 comes in front of the x, and that's why we get 3x minus 2. And over here, 9 over 3 becomes 3. So either method works. You can do grouping or the way that I like to do it. So 3x minus 2 times x plus 3 is the right answer. Okay, so let's move on. Now, we reviewed factoring because what we're going to do now is go back to factoring quadratics in order to find x-intercepts. Essentially, what we're going to be doing is we're going to be replacing y with 0, which if we pretended that this 0 that I'm pointing at was a y equals x squared plus 2x minus 8, that's a parabola, right? It's a parabola that looks like this, upward parabola. But when we're searching for x-intercepts, where this graph touches or crosses the x-axis, if you want x-intercepts, you replace 0 for y so that you only see x, and you solve for x. So one way to find these x-intercepts is you replace 0 for y, all terms on one side. One method is factoring. So in this problem, we got all terms on one side, we factor, and then you can set each factor, like x plus 4 equal to 0 and x minus 2 equal to 0, and you solve. And whatever you're solving for, those are x-intercepts, where this parabola, where this U-shape touches the x-axis. So for here, for this graph, it touches at negative 4 and 2. Okay, so that's one thing that helps us draw this picture. We also know that for this problem, if this was y equals, we know that a comma c is the y-intercept, so we know that there's a y-intercept down here. And that's enough info to kind of help us draw this picture of the graph. So let's continue. So I wanted you to kind of understand what we're doing. It all stems from quadratics, but we're specifically finding values to help us draw a picture, values that might lie on the x-axis. Okay, so up here it says zero product property. Basically what that means is when you have quantities that are products, when multiplied that equals 0, you can set those expressions equal to 0 and solve. So if you look at 4, 5, and 6, it's already set up for you. If you have all terms or factors on one side and 0 on the other, you can set your factors equal to 0 and solve. So if I set 2x plus 3 equal to 0, oops. 2x plus 3 equal to 0. And I solve, I'll subtract 3, so I get 2x is negative 3. And then if I divide by 2, I have one of the x-intercepts is going to be negative 3 over 2, or 1.5. And then our second we set equal to 0. So if I set 3x minus 1 equal to 0, I would add 1 to both sides, so I get 3x equals 1. And if I divide by 3, I get x is 1/3. So those are our two x values. So this, if I FOIL this and this was a problem, we replace this with y, this graph would touch the x-axis at -2.5 and at 1/3. Similarly for this next one, if we set each factor equal to 0, I know that if I set x plus 3 equal to 0, I subtract 3 and I get -3. So that's one value. If I set this other factor equal to 0, right, 2x minus 1 equals 0, we can add 1. Divide by 2. And so our other value is 1/2. Again, if I FOILed this and I had replaced this 0 with a y, it's an upward parabola, and we would have values touching the x-axis at -3 and at 1/2. Then we'll look at this last one before the next video. So if I set each factor equal to 0, if I set x minus 9 equal to 0, right? X minus 9 is equal to 0. So 9. If I add 9 to both sides, I get x equals 9. Remember, you have to solve, so it's not -9, it's positive 9. And if I set 5x plus 2 equal to 0, you subtract 2 first from both sides. So we get 5x equals -2. Divide by 5, so x would equal -2/5. So again, if I distributed, I'd have positive x squared. If this was a y, it would be an upward parabola. And we know based off these values that we would have a dot on the x-axis at 9 and at -2/5.